Let's talk about Python functions in the Python programming language. So we're going to be using Python a lot, and functions are one of the major tools we'll be using. To start off with, let's look at how we could implement something like f of x equals x squared in Python. Here I have one way I could write it. Def square of x colon y equal x times x, return y. Now there are some pieces to this. One is the def. Def is a keyword that tells Python, I am defining a function. Then there's the name of the function, which in this case is square. There's the input to the function, which is going to be x. And then there's a colon to tell it ending the line. Another piece that I haven't talked about, but there needs to be white space underneath the def. So when I'm doing this, as I'm writing this function, I should hit space. It automatically indented it. If it didn't, I would need to space 4 times to get that even. And then the final pieces are a return statement. The procedures to compute. So I'm going to define something called y, which is equal to x times x. And then y is actually the thing that the function is going to spit out. So remember, we're thinking of functions as things that eat inputs and spit out outputs. And return y is actually the spitting out part. One Python syntax thing, I've used y equals x times x, but exponentiation in Python is represented by 2 asterisks. So we could write x squared as x asterisk asterisk square 2 in Python. Once we've defined a function, we can evaluate that function at an input by plugging in an appropriate input. So, escape B. Okay, so now I'm going to define, so let's say I want to actually write a number, so my num equals square 3. It tells me it doesn't know what square is. That's because I forgot to hit shift enter on that. So my num equals square 3, and then if I need to know what my num is, I could do print my num. You think of this like your algebra calculus intuition. You think of a function of g of x, something like g of x equals 3x squared minus 1. Notice this actually contains a lot of information. You have the function name, g. You have the input to the function, x. And you have, sort of implicit in this, an algorithm for computing the output. Square x, step 1. Square x, step 2. Multiply the result from step 1 by 3. Step 3. Subtract 1 from the result in step 2. Step 4. The result from step 3 is your final answer. So this is an algorithm. And if I wanted to implement it in Python using this sort of step-by-step process, I could do it with these intermediate variable calculations. I could actually say step 1 creates x squared, or I could do x asterisk asterisk 2 to achieve the same result. Step 2 is 3 times step 1. Step 3 is step 2 minus 1. And then return step 3. That says the answer from step 3 is my final answer. Of course, this isn't the only way to do this. There are lots of different ways you could do this. And so below I'm going to define it a function alt g, which does the same thing as g of x, but in a different manner. So if you wrote functions in Python before, you probably tried to make them look more streamlined like this. Writing it this way emphasizes the logic of what's happening. Writing it this way is more efficient, probably to compute, and actually easier to see. One more thing to mention, you can also have functions in Python that take more than one argument. So here I have a function add 2 numbers num1, num2, and it does what it says it should. It returns num1 plus num2.